H.C. Verma, Wave Motion and Waves on a String, Question 10. Here is the setup. The displacement of a string is given by y equals 1.0 mm times sine of pi over 2 centimeters times x minus pi over 0.01 seconds times t. This is a sinusoidal wave traveling in the positive x direction. Let us visualize it. Here is the full question. Given the wave equation, part A, find the time period capital T and wavelength lambda. Part B, find the equation for particle velocity and the speed at x equals 1.0 cm, t equals 0.01 seconds. Part C, find speeds at x equals 3, 5, and 7 centimeters at t equals 0.01 seconds. Part D, find speeds at x equals 1.0 cm at t equals 0.011, 0.012, and 0.013 seconds. The key concept. From a wave equation y equals amplitude capital A sine of wave number kx minus omega t, we can read of wave number k and angular frequency omega directly. Period capital T equals to pi over omega. Wavelength lambda equals to pi over k, particle velocity, is the partial derivative of y with respect to t, which is negative amplitude capital A omega cosine of the argument. Part A. From the given equation, wave number k equals pi over 2 per centimeter, and omega equals pi over 0.01 which is 100 pi per second. Period capital T equals to pi over omega equals to pi over 100 pi equals 0.02 seconds, that is 20 milliseconds. Wavelength lambda equals to pi over k equals to pi over pi by 2, which gives 4.0 centimeters. Part B. The particle velocity equation is Vy equals negative amplitude capital A times omega times cosine of kx minus omega t. Substituting, Vy equals negative 1.0 mm times 100 pi times cosine of pi over 2 times x minus 100 pi times t. At x equals 1 centimeter, t equals 0.01 seconds, the argument is pi over 2 times 1 minus 100 pi times 0.01, which equals pi over 2 minus pi, that is negative pi over 2. Cosine of negative pi over 2 is 0. So the speed is 0. Part C. At t equals 0.01 seconds, we check x equals 3, 5, and 7 centimeters. For x equals 3, the argument is 3 pi over 2 minus pi equals pi over 2. Cosine of pi over 2 is 0. For x equals 5, the argument is 5 pi over 2 minus pi equals 3 pi over 2. Cosine is again 0. For x equals 7, the argument is 7 pi over 2 minus pi equals 5 pi over 2. Cosine is still 0. So all speeds are 0. These points are at their extreme displacement at this instant. Part D. At x equals 1 centimeter, kx equals pi over 2. We evaluate at 3 different times. At t equals 0.011, omega t equals 1.1 pi. The argument is pi over 2 minus 1.1 pi equals negative 0.6 pi. The absolute value of cosine of 0.6 pi is 0.309. Speed equals amplitude capital A times omega times 0.309, which is 0.1 times 100 pi times 0.309, giving approximately 9.7 centimeters per second. At t equals 0.012, the argument is negative 0.7 pi. Absolute cosine is 0.588. Speed is about 18 centimeters per second. At t equals 0.013, the argument is negative 0.8 pi. Absolute cosine is 0.809. Speed is about 25 centimeters per second. The correct answers. Part A, period capital T is 0.02 seconds and wavelength lambda is 4.0 centimeters. Part B, speed at x equals 1, t equals 0.01 is 0. Part C, all speeds at x equals 3, 5, 7 are 0. Part D, speeds are approximately 9.7, 18, and 25 centimeters per second. Here are some important tips. Tip 1. Read wave number k and omega directly from the equation. Do not try to find wave speed v first. Tip 2. When cosine of the argument is 0, particle speed is 0, the particle is at maximum displacement. Tip 3. When sine of the argument is 0, particle speed is maximum, the particle passes through equilibrium. Tip 4. In part D, notice the speed increases as the particle moves from extreme to equilibrium position. Like and subscribe for more HC Verma solutions at MAGPIEHUB. See you in the next video.